We have been analyzing this situation here by drawing a free body diagram and determine the magnitude of the forces acted on this body over here. Then from this magnitude of the forces and these angles that we have here, we try to determine the work done, and we have explained what does it mean if our work done is positive, negative, or zero. So now we are going to talk about a new concept which is called total work done. So we know there are multiple forces acting on an object here, and in chapter 4 we learned that the effect of it is determined by the net force, and net force is like the summation, the vector sum of all the forces acting on an object. So now if I want to talk about work done, but I want to talk about the net work done, or the like all this work done add together, what will be the final work done, things like that. So how do we do a sum for all this work done that we have here? Well, if you remember, work done here is a scalar quantity. So when it's a scalar quantity, it does not involve any direction. For forces, it involves direction. So if you want to sum them up, you have to resolve into components, add them up, do Pythagoras, do trigonometry in order to find the resultant force. But work done, since it's a scalar, it has no direction. So to determine the sum of it, it's much more easier than doing the summation of forces. Because for here, you just add them up arithmetically, just like how you usually add up numbers. So because work done is a scalar quantity, it has just only magnitude but no direction. And because it has no direction, we have nothing about direction to be careful about. So we can just do an algebraic sum of all the work done by individual forces. So what does it mean is, if you want to find the total work done, or the some people call it net work done, of all the forces acting on an object, you can just add up all the work done that we have calculated here. So the total work done is equals to the work done by external force plus the work done by gravity plus work done by normal force and the work done by kinetic friction. So you have all these values here, you just sum them up. If it's negative, then make sure to include the negative sign. So once you summed up everything here, you get 385 joule, and this is the total work done that is being experienced by this object over here due to all the forces acting on an object. So this is the first method of determining work done, and it is by doing the algebraic sum of work done by all individual forces. But you can also have another method of calculating total work done. So the second method will be to find the work done by the net force acting on the body. So previously we find the work done of all the forces individually, then we sum up the work done. But there's another way, which is to find the net force first by summing up the forces, finding the net force first. Then from the net force, we calculate the work done using Fs cos theta. Just that now Fs cos theta become sum of F, the net force times S times cos theta. Okay, so let's try and look over here. So for the x component, we take the x component of the external force minus the kinetic friction. So we are finding what is the net force in the x dimension, and you find it to be 38.5 Newton. And since it's positive, that means this net force in the x dimension is pointing to the right. Next, we have our sum of F in the y direction. We take what's pointing upwards as positive, so n plus the y component of external force minus what's pointing in the opposite direction, which is the weight pointing in the opposite direction. So you have all the values here, you just do your substitution and you get your sum of F in the y dimension to become 0 Newton. So the net force here is acting in the x direction. There is no net force in the y dimension. So once you find all the x component and the y component, you can proceed to find the magnitude of the net force by doing a Pythagoras theorem to combine the x component and the y component. And this is what you get. Well, and for the angle here, you do need to use tangent theta to determine the angle, because you know that there's nothing pointing in the y dimension. So if this is positive, that means this is pointing to the right. If this is negative 38.5, then the answer will be 38.5 Newton to the left, if it's negative. Okay, so now you have determined your net force already. You know the direction, you know the magnitude. What you do now is just to find the work done by the net force right now. So for now, work done total, the total work done is now equals to the scalar product of the net force and the displacement. Net force and displacement, not individual force. you're calculating total work done, means by the work done by all the forces acting on an object. So it has to be net force, scalar product with the displacement. So net force times displacement times cos theta is now a method of substitution. The magnitude of the net force is 38.5. The displacement that we have here is 10. If you remember from the example, I didn't write here, I should put it here. It's 10. Then for cos theta, you know the displacement is going to the right, and you know the net force is also to the right. So the angle between sum of F and displacement is 0. They are in the same direction. So 38.5 times 10 cosine 0, then that's what you get, 385 joule. So as you can see here, using method 1 and method 2, you are able to obtain the same answer for total work done, and they both give out the same answer, 385 joule. So there's two ways of calculating work done. One is by finding the work done by all individual forces first, then add them up using algebraic sum. No need to care about vector here. Another way of doing it is finding the net force here. So when you're finding a net force, you need to do a vector sum. You need to find your x dimension, y dimension, combine them, find the angle. Then after you have done all this, you proceed to find the total work done by doing a scalar product between the net force and the displacement. So these are two different methods of calculating work done, but they will generate the same answer.